All right, so let's get started. I know it's 9:01. I see some folks joining. We'll have more people join just in about a minute or so. But good morning, good afternoon, everyone. Welcome to our session today. I'm super excited to have one of our services partners. It's a StreamNative services partner, Nexaminds, join us today. We're going to be talking about Kafka migration and best practices, and also introducing you to the universal linking tool, which we launched recently. So before we get started, I'd like to introduce our Nexaminds team. So Tej, do you want to introduce yourself first?
Hello, everybody. My name is Tejpal Dallan. I'm based in the East Coast near Washington, D.C. I have been a technology guy, been responsible for business applications, technology, shared services, and platform. And here at Nexaminds, I'm responsible for solutions and sales engineering, and really looking forward to this exciting event. Thanks for joining, everybody.
Awesome, great. Memo, do you want to go next?
Yeah, hello everyone. Nice to be here. Thank you for the invite to the StreamNative team. My name is Guillermo Hernandez. I'm based out of Mexico and I'm a senior data engineer here in Examinds. And yeah, I will be sharing with you some of the best practices when it comes to Kafka migration.
Perfect, awesome. And then I'm joined by Dustin from StreamNative. Dustin, do you want to introduce yourself?
Sure. Kun and I have done multiple webinars now together, but I'm StreamNative's technical trainer. I've been here a couple of years. If you watch any of our StreamNative Academy YouTube channel videos, you may have heard my voice, maybe not seen my face on as many videos. But yeah, I'm excited to be here. I'm going to give a short demo as well of UniLink today.
Perfect, awesome. Thank you so much. And I'm Kundan Vyas. I'm part of the product team here at StreamNative. So let's get started. Thanks everyone for joining. So we want to keep the agenda very focused on Kafka replication today. I'll get started with talking a little bit about the use cases and the challenges we're hearing from like different organizations, different enterprises as we talk to them. We'd like to definitely talk a little bit about that. And then we want to actually get into the introduction of universal linking tool. We announced this, I think, a couple of weeks back in public preview. So we'll walk you through that. And then Dustin is going to do a quick demo covering a particular flow, which will give you an end-to-end idea about the value which universal linking tool provides. And then we'll come back again and talk more about, what sort of best practices should be kept in mind by organizations who are kind of moving between their Kafka clusters, and particularly, do they always have to kind of just move away from one cluster to another, or are there options where they can sort of keep the lights on with the source cluster for some time and then test it and then can switch. So we'll explore all those options, and then we'll have some time for Q&A as well. So let's get started. So a quick introduction to StreamNative for the folks who don't know about StreamNative. StreamNative is a company created by the founders of Apache Pulsar. So Apache Pulsar was created as a technology back in 2012 at Yahoo. It was open sourced, and it's a part of the Apache Software Foundation, and it made its way to being a top-level project in 2018. And in 2019, the company StreamNative was formed to offer fully managed services for Apache Pulsar. So these 4 years, from 19 to 23, the Apache Pulsar community saw a really good growth, and also did the company StreamNative. So I think that was a phenomenal phase for us. 2024, basically, we realized that a lot of the problems we were solving, particularly the challenges which Apache Kafka had, were solved by Pulsar, and we wanted to kind of offer those capabilities to the broader Kafka community as well. So we can enable Kafka compatibility on top of our infrastructure, so the broader community from Kafka could also benefit from all the value we were providing through the problems we were solving with Pulsar, right? So that's when we kind of started offering Kafka solutions as well. So StreamNative is now both a Pulsar and a Kafka vendor. So I think, keep that in mind, right? Okay, so that's a short introduction for StreamNative. I'm going to hand over to Tej to do a quick introduction on Nexaminds, and then we'll get started.
Thank you. Let me introduce you to Nexaminds. Here, our mission is to be a forward-thinking AI-powered technology services company. And at our core, we're passionate about using the power of AI, and our mission is to drive meaningful transformation. We collaborate with our clients to reshape their industries and create a smart, innovative future for them. So this QR code links directly to more information about us. Please feel free to scan it, um, and we can move. Yeah. So here I'm trying to say that our core team, we bring a decade of proven leadership of growth and trusted partnership in technology services area. We've supported top tier organizations across streaming, e-commerce, automotive, insurance, consulting, and our expertise is backed by our partnership with StreamNative, with Google, with HashiCorp. Our talent pool is now increasingly global, and what kind of sets us apart is our nearshoring model, where we kind of leveraging the talent based in Mexico. And Mexico does offer some unique, compelling propositions for us, like being close proximity to most of our clients, the time zone advantage that we get out of it, the cultural fit, ease of immigration, and Mexico has increasingly a very large engineering talent pool. And so we're able to leverage that, and we're now also expanding to India for some other global time zones that we will be able to support better. Like this happened in the last 2-3 months. We've been expanding to India and Canada as well. And you can see the list of our clients, very recognizable brands, and they trust us to build robust practices of DevOps and SRE and software engineering and quality engineering for them. So yeah, we can move to the next slide, please. Yeah, so at our heart, right, our offering is custom software development. We try to tailor solutions designed specifically for our clients' business needs, and we strive to kind of create, develop and craft software that fits their needs. And uh, one of the things that we're focusing on recently is data science, and that's where our partnership with StreamNative comes in. Our team also is striving to leverage AI, machine learning, data engineering to uncover insights and opportunities to fuel growth for our clients. Then we have good user experience, UI design engineers, and that helps us focus on giving seamless user experiences that are not only visually appealing but actually serve the users of our clients. So then we also offer very robust QE practices. Our QA and testing, both manual as well as automated, offer solutions that are pretty rock solid and ready for a lot of eventualities that that our clients might be facing. And we also have significant platform and infrastructure expertise. Our DevOps and security engineers have built and maintained environments that are fault tolerant, scalable, secure, and we put a lot of emphasis on data engineering of late, and we're leveraging big data analytics, business intelligence, predictive analytics, secure data management to transform raw data into strategic assets for our clients. So yeah, this is some of the technology stack that I was talking about. Moving on, some of our offerings, basically the three core pillars that we offer for our clients. Starting with agile development, our approach has always been API first design mindset, enabling seamless integration across systems. We deploy full stack squads capable of working across multiple client cloud environments, allowing us to be scalable and agile. And our cloud first application development strategy, we focus on building natively for the cloud to begin with. And we like help with containerization and orchestration for our clients. We ensure that the apps are scalable, resilient, portable, and we have expertise in CI/CD pipelines for rapid innovation, quality engineering, and high performance applications. And intelligent DevOps is all about speed, stability, self service. Our DevOps practices include release engineering automation, service mesh automation for microservices, and cloud migrations, deployment support. So we enforce compliance through policy as code, ensuring governance is baked into our delivery process. And like finally, the operation automation is where we focus on reliability and resilience. We offer SRE practices, continuous monitoring and observability for proactive insights. We have performed chaos engineering for stress test systems in controlled ways. We have designed rollback mechanisms as part of release management, and we are also into ML ops for some of the AI solutions that our clients are trying to get into. And then on the right hand side, like the delivery models that we offer, it's outcome based or staff augmentation. For both of them, you get a customer success manager, and we typically follow the agile methodology, and the pricing varies. For outcome based, it is tiered into deliverables, milestones, while staff augmentation is obviously based on like hours and pod sizes. And for team composition, we manage the pod ourselves and let the partner decide depending on what kind of model that you want. And yeah, lastly, like governance as outcome based delivery includes full end-to-end project management, and in staff augmentation it is defined collaboratively with our client partners. So this dual model approach gives our client the freedom to scale and innovate at their own pace with the right level of control and commitments from us. Yeah, that's it. Thank you. Yeah, Kundan.
Okay, awesome. That's great. Thank you so much, Tej. So, I mean, as you can see, Nexaminds definitely has a very broad set of skill set here to help you with your end-to-end journey for your data platform, while StreamNative is very focused on solving your problems related to the platform itself and offering you a cost-optimized way to kind of host your platform, data platform. I think Nexaminds comes in to kind of hear your end-to-end story, all the things, all the other use cases related to integration and the peripherals around sort of your core platform itself. So we'll share more about how you can sort of get in touch with them. But I think I'm excited to kind of partner with them in solving this end-to-end journey related problems for data for all the customers. Cool. So let's get started then for today's topic. So we want to talk about Kafka replication, particularly, there are quite a few use cases, but I think I want to really focus on two first, and then we'll definitely get into the other ones. So I think there are two main use cases right now we are aiming at actually focusing on with some of the lot of organizations we are talking to. Actually, there are two areas where they are seeing a lot of challenges, and that's why we have decided to kind of prioritize these. The first one is really about real-time data lakehouse. So this is really about enabling the existing Kafka deployments to be able to kind of stream data and get ready for the new Gen AI based projects which are happening within the company. Everyone's kind of focusing on having a team focused on Gen AI and getting more value out of their data. So they want to like sort of not really shake up all their existing deployments, but at the same time they want to kind of make sure that they replicate data coming out of their source Kafka clusters to kind of enable the existing data analytics teams or data science team be able to get what they want out of it. So the very first use case is really about that, essentially just keeping your Kafka cluster on, but replicating data which is coming out of that, storing it in open lakehouse formats. So it's ready and available for third-party teams to be able to query using their favorite tools, whether it's a proper data warehousing tool or data lakehouse type of tool, like Snowflakes and Databricks, or like it's just another like third-party tool, open source tool like Trino and others, right? So this one is really about that. So we'll talk a little bit about what sort of problems we are solving in this space. The second one is really the classic Kafka migration use case, where let's say if in this journey, as you start with exploring the real-time data lakehouse, enabling your existing Kafka deployments for to kind of do more with data, and also enable that for the third-party teams to take advantage of that data. Once you're ready to kind of move away from your source Kafka cluster, you can make that decision and do the switch. And this scope of this use case is really about switching all your source applications, Kafka applications, to the destination cluster after the replication, and then decommissioning your sort of source Kafka cluster. So we'll talk a little more about that as well. But essentially, for replication, there are a couple of different things to keep in mind. There are some tools out there which have been around for some time, right? So I think particularly for Kafka replication, there are a couple of open source tools like Mirror Maker, UReplicator, and then there are tools from Confluent, right? These are the commercial tools. So now the tools like open source tools like Mirror Maker and UReplicator, there is a regular active contribution to these tools. So there is definitely progress happening there. And there are also certain organizations using them today in a self-managed fashion. But I think, these tools come with definitely a lot of gaps around like how offsets are managed or schema is replicated. But I can definitely say that they're definitely getting better, and there's contribution on that. Confluence tool, on the other hand, definitely has done a great job. Like I think they've actually essentially addressed a lot of these challenges with the open source tools have. But I think these tools definitely come with a certain range of like costs, particularly the networking costs which you incur when you use these tools based on the scenarios can be really high. But they do solve operational complexity, right? But the cost still is one of the biggest challenges in the brave new world where we live in today. So I think it's definitely a sort of concern everybody keeps an eye on, right? So we've been tracking these challenges. And I should say that from a StreamNative's perspective, there are two principles which have been really important for us while trying to solve the problem and also try to design a solution for a problem. The first one is really the interoperability. This is the part where I was referring to before, where we started off with the Apache Pulsar solving a lot of problems which Kafka had for a long time, and Pulsar solved those problems, right? And then we want to kind of roll out those solutions to the broader Kafka community by opening up our infrastructure via Kafka compatibility API. So any problem we solve, we can at least keep an eye on how we will be able to, how can we sort of roll that out to the broader communities between Pulsar and Kafka. And that is what we mean by interoperability between sort of our different types of protocols we support for interaction with our platform, right? So both Pulsar and Kafka. We have other protocols too, but I'm referring primarily to the data streaming related ones right now. And from a cost effectiveness perspective, this is really another important aspect. When you're trying to solve a problem, one thing I've noticed with a lot of solutions out there, the commercial ones, that while they will offer a good experience, they might very quickly get expensive as you start scaling your data or your platform, right? And that can again become a problem for adoption, because if you build and offer a very good experience, which is fully managed with a good ecosystem and everything around it, but as you start scaling it and cost becomes a concern, then again literally adoption starts hurting there. So the second thing which we keep in mind is to really make sure that as we solve the problem, we want to make sure that as customers scale up the use of our platform, that doesn't really start hurting them from a cost perspective. And of course, there's a lot of work we also have to do on that. But I think at least that's a goal from our vision perspective. So I want to talk a little bit about Universal Linking Tool, which is our Kafka replication tool. Today, it only focuses on Kafka, but over time, we'll talk more about support for Pulsar and other capabilities. We announced this, I think, like a few weeks back. This is basically a fully managed service within StreamNative Cloud, which allows you to replicate your data from source Kafka cluster into either your destination your cluster within StreamNative Cloud, or you can also have replication done in such a way that you don't have to decommission your source cluster. You essentially replicate your data to a low-cost object storage, so that that data then is accessible to third-party tools who don't always need the Kafka consumers and producers type of applications to build pipelines. They could just use the replicated data, which is stored in open formats for querying from third-party tools. Right now, the beauty about this tool is, again, it's fully managed, available out of the box in the cloud, and has a good UI, which is very declarative for you to being able to connect to your source cluster and can start replication jobs, right? The one of the biggest focuses we've had is to kind of make sure that the tool does a good job from a replication perspective. It ensures that all your data, metadata, configurations are all replicated. So with data, I mean topics, and then configurations and consumer groups, all the things which are relevant for you to be able to switch your source Kafka applications to a destination platform or a cluster without much of interruption, right? So definitely that there's a lot of focus which has gone in that, and we offer a full fidelity replication for that. It's cost effective by design, because I think one of the unique things about UniLink is that, unlike a traditional replication tool for Kafka, which replicates data from source to destination cluster directly, here we replicate the data to a low-cost object storage service. Like in this case, on AWS, it's S3, and then on other platforms, other cloud providers, it's their respective cloud storage services. So we replicate the data, store it in our URSA format, and then we sort of convert that to sort of the open lakehouse formats like Delta Lake and Iceberg after doing the compaction. So that way, it's the data stored in this format is accessible to the destination cluster, which starts to start consuming and building the pipelines. And also, let's say if you want to enable direct access for your data science teams through the third-party tool, they can directly talk to the data store. Now, with this approach, is very cost effective for us because we skip a lot of cost related challenges like networking and a whole bunch of other compute related costs which you incur when you start actually replicating from source to destination cluster directly. And we do have a lot of resources to share around how we help with the cost, and I can definitely share that at the end of this call around it. But I think this is a very important aspect to keep in mind, that this replication tool particularly focuses on resolving a bunch of cost-related issues, right? Third thing I'll quickly say is it works with most of the Kafka deployments out there, like Confluent or MSK, Red Panda, any self-hosted Kafka. You can connect to that as a source Kafka cluster and sort of be able to replicate the data. So I think this is available today within StreamNative Cloud. I'll share more details shortly at the end of the session of how you can try that out. But universal linking is something which is very declarative. And I think Dustin is going to show us a good demo around this. But this is really the aspect I want to, again, highlight one more time before I move on. So again, here for the two use cases I was talking about, the real-time data lakehouse and the Kafka replication or migration use case, right? So the real-time data lakehouse is where this is where you have your source cluster, keep it on, do not disturb it. You don't have to decommission it. But if you want to sort of enable, Gen AI-based projects with, replication of data coming through this cluster, you can use this tool as a live link to replicate the data and enable your data science teams to or other teams to be able to work on those projects, because now the data is open and it's all the innovations which are happening in the Delta Lake and Iceberg space is something which they can take advantage of. While that is happening, you can also, of course, replicate data into another cluster if there are other teams who want to build the traditional pipelines and take advantage of that. Once you're convinced that you no longer need your source Kafka cluster and you're happy with the new platform which StreamNative provides, then you can do the switch and decommission the source Kafka cluster. And that would sort of become the Kafka migration scenario, right? So I think it's a good way for you to do a live testing and keep it on for some time, and also not just like for testing, but keep it live for a use case like real-time data lakehouse before actually considering switching, right? So you have you can validate a lot of things before like rushing through it. So the tool kind of helps you do that. All right, so I'm going to, in the interest of time, rush a little faster. We have a demo coming up soon. So I think just to highlight the fact that universal linking tool for Kafka replication is unique in a way where we are using object storage for replication, unlike other tools who directly go from one cluster to another cluster, where there are lots of scenarios where a lot of cost is incurred. So we take advantage of leveraging the object storage for that. And also, I think, particularly around the way we support different types of formats, we cater to different types of consumer clients we have. And then, we optimize how data is stored in certain formats. So it's more quicker based on the use case for your different clients to kind of read that data. There are other use cases too when it comes to Kafka replication, which are popular, but I think we are not focusing too much on that right now, although UniLink definitely supports a lot of scenarios here. And over time, we'll come back to you to talk more about how UniLink can help you with perhaps a disaster recovery or some of the other capabilities like global data streaming, right? So we definitely have these use cases in mind, but we'll come back and talk more about that in depth later. So with that, I'm going to sort of hand it over to Dustin to walk us through the tool, show us the product, and then talk about the scenario which he's going to show us today. Dustin?
Sure. If you want to stop sharing your screen. Also, if attendees have any questions, you can drop them in the Q&A. This would actually be a good time because then Kundan can take a look at them while I'm doing the demo, and he'll come up with some answers that he can give at the end of the session. So yeah, if you have any questions, feel free to drop those in the Q&A. This demo is a little shorter than what I've done in the past. I have some stuff on StreamNative Academy's YouTube channel. Kundan, can you see my screen? Does it look good, the IntelliJ?
Yes, I can see the IntelliJ screen. Yep.
All right, I'm going to go ahead and start up a producer and a consumer here. This is going to be producing and consuming from what would be considered your legacy cluster. So this has nothing to do with StreamNative yet. This would be your Kafka application is running as is in production. And we're kind of going to go through both of those use cases that Kundan talked about. One is to enable the data lakehouse, and the other is to actually migrate the Kafka application. And we were going to focus more on the Kafka migration in this demo, but I'll kind of talk to the other one as well and show that data at the end. So here it's on the left, you can see it says it's publishing to the legacy Kafka cluster. Here we're consuming those messages that were originally published from the legacy Kafka cluster, and we're consuming them directly from the legacy Kafka cluster. So nothing to do with StreamNative yet, nothing to do with UniLink. So what we want to do is now move this application over to our Ursa cluster. So I've actually already spun up a cluster that is here in StreamNative Cloud. It's a BYOC cluster. So if I go into my instance here, this is the cluster I'm going to be using today. If I go to the configuration, you can see here I have a Snowflake backend, or I have going to be saving the data in Iceberg, and then I'll be able to view it in Snowflake. And then this is the cluster we want to migrate the application to. So we're going to use UniLink to do that. So I've already got UniLink running as well. So if I go here into UniLink, I've got my schema migration going already. So if I move my consumer over, it's going to be able to read the data because the schema should already be there. And then the data migration here is also active. So the data that I'm publishing on the source cluster should already be getting moved over here to the destination. So if I go back into my cluster, take a look at my public tenant, default namespace, go into my topic. We're using Kafka test 12 right now is the one I'm publishing and consuming from on the legacy cluster. You can see that there's already data that's getting into it. So while I'm producing and consuming on that legacy cluster, UniLink is already starting to move that data over into this cluster. And then this data would be viewable inside of something like Snowflake at this point without ever moving the producers and consumers over. But we want to focus a little bit more on the migration today. So if I go back over to my IntelliJ, I'm going to go ahead and stop my consumer here. So we're going to say your AI team has been, or you've been copying that data over. It's compacted into Parquet files, readable in Snowflake or Databricks or Amazon S3 tables. Your AI team likes that data. You want to completely move over to the Ursa cluster now. So the first thing we would do here to migrate that application is I would stop the consumer. And I did a hard stop on it, so we may have lost one or two acknowledgements. If you have a actual production system, you'd have a shutdown procedure to make sure all messages got acknowledged. But when I start up the consumer on the destination cluster, because the schema has already been migrated and the offset that the legacy cluster for this consumer group should be migrated as well, the new consumer should be able to pick up exactly where it left off, all while the producer has continued to run without any changes. So I'm going to start up a consumer here. It looks like we're about 60 seconds in. I actually have the offsets set to transfer over every 15 seconds. If you were doing an actual production crossover, I would validate the offset has been moved. But I'm going to trust it without doing a validation here. And let me start up a consumer on that points to the destination cluster. And again, I'm using the same consumer group, so the offset should get picked up. So if everything went okay with the schema migration and the offset migration, this consumer should work just fine on the destination, picking up all of these messages, but starting where it left off. Let me see if I actually get this working. So it started at 145. I think the other one stopped at 147. That's probably the acknowledgements got lost because of the way I just did a hard stop on the consumer. But the offset is going to be migrated exactly from the legacy cluster into the StreamNative cluster. And the offset is going to be valid because we're doing a byte for byte copy of the data from the Kafka cluster into that destination cluster, that topic. So these are messages now that are being published to the legacy Kafka cluster, but consumed on the StreamNative cluster. So the data flow at this point is data published on the legacy cluster, copied with UniLink, as Kunin had said, directly into object storage. So it's not going through the broker on the destination. That's going to cause huge cost savings by not having to take that network path. The Ursa cluster will pick those up and make them visible in our topics. And now this one's consumed from the StreamNative cluster. At this point, everything's going great with the consumer, so I can go ahead and stop my producer on my source cluster. The last message that got published was 309. So this is where your application, you would do a cutover. The last one that got consumed is 309. So if I were to start up my producer on my destination cluster, I would want to start it at 310, basically telling it where to start your application again, what data needs to be moved. So I'd start up producer 2, click run. Again, this is the exact same Kafka code, just moved over to the destination for both the producer and the consumer. I have separate ones here, but it's the exact same code with two changes. The API key switched out and the endpoint of both the producer or to the broker as well as to the schema registry. Those two endpoints have to switch out. So now we're publishing directly to StreamNative and consuming from StreamNative. So we finished the migration of the data. Since this is what I wanted to focus more on this demo, but because there is all of that added benefit of using Ursa, of getting data into Lakehouse storage in open formats like Iceberg and Delta Lake, and then being able to view it in Databricks, Snowflake, or Amazon S3 tables, I want to show you what that looks like real quick in Snowflake because I've had Snowflake running this whole time secretly. I kind of showed you that I had the cluster already set up to use Snowflake. But let's take a look at this one. This is Snowflake Open Catalog, and we were using Kafka test 12, but the compaction service on this cluster takes about 5 to 10 minutes for it to show up. You can actually tune that with our engineering team, and in some of my older demos, we had that tuned down to 2 minutes so that I could quickly show it. But 12 hasn't shown up yet, but I did 11 just before this call. 11 is showing up here. The schema is showing up here inside of Snowflake Open Catalog. 12 still hasn't shown up, but it could show up any second. But we're trying to make a short demo today. So 11, the data's already here. So if I then go into Snowflake, There's a couple steps in Snowflake. You got to make an external volume and a catalog integration. And once you do that, you'll be able to see here's Kafka test 11. All of the data is viewable in Kafka, regardless of where it was published. So if I go back and look at the historical data, I see the data that was published to Kafka. And then when you do the cutover, I did it similar for this one just before the call. I did a cutover to publish to StreamNative, and all of that data is viewable in Snowflake. Completely seamless, does not matter where it was produced, where it was consumed. All of it gets copied over, and all of it looks identical once it's in those Parquet files and is consumable by Snowflake Databricks or Amazon S3 tables. Again, the compaction service is a little bit slower on this cluster today because we weren't focusing on this part of it. But you got to see the migration and process and what that data looks like in Snowflake. So I'm going to hand it back to Kundan.
Awesome. Thank you so much, Dustin. That was really great. And there are so many different use cases, as said, like Dustin has actually created, let me share my screen back. Hope you can see the screen now. Dustin, Kafka migration. There are some resources we're going to share at the end of this session where there are some videos from Dustin which are like even more detailed around the type of capabilities it covers. So this is really, hopefully you got a quick sense of what the tool offers as a capability. We'll chat more about that in a bit. But again, thanks, Dustin. Let me just come back here. So I think now what we want to talk about is actually some of the best practices. So I think the two use cases which we spoke about, real-time data lakehouse and migration. I think, while universal linking tool sort of really helps you do that, I think you don't always have to sort of, if you want to, you definitely can log into StreamNative Cloud and get your hands on it. But if you still want to talk more about, if you have more questions about best practices, you can always engage with someone like, Nexaminds. So with that, I'm going to hand over to Memo to kind of cover some of the best practices here to keep in mind as you're planning your migration, right? So Memo, over to you.
Yeah, thank you, Kundan. For those who connected a bit late, hi everyone again. My name is Guillermo Hernandez, Senior Data Engineer at Nexaminds. Today I'll be walking you through Kafka migration best practices. This session is focused on real-world strategies for migrating Kafka clusters. Whether you're moving from on-prem to cloud, or maybe upgrading platforms or modernizing your data stack, you'll also see how StreamNative's UniLink can be a central piece in making migrations smoother, safer, and more efficient. So this is a high-level explanation of a plan with different steps and phases that you can follow to have a safer Kafka migration, really with the help of UniLink. Let's start with a big question. There are some use cases. Why migrate Kafka at all? It could be more use cases, but in our experience, there are four common reasons. First, infrastructure changes. Organizations often migrate from on-premises cluster to managed services like AWS MSK, Confluent Cloud, or a Pulsar-based alternative such as StreamNative. And second could be the consolidation. Maybe you have grown through acquisitions or have fragmented environments that need to be unified, or maybe the opposite. Maybe you need to isolate data pipelines by business units or maybe by regions. So that could be another use case. And the third, maybe upgrades. Older versions of Kafka may not support your currently security or performance needs. So that could be another use case. And lastly, maybe you want to improve your cost and performance. You want to custom performance optimization. So in this case, maybe you have identified that there are tools like UniLink that can help you to improve throughput and reduce operational burden, right? So Kundan mentioned some of the challenges with Kafka migration, but I wanted to list some of them here. So the scary part comes, that is what can go wrong, right? there are some challenges that you may face while working on your migration process. So yeah, migration often risk data loss or service interruptions if not handled carefully, right? That is the first one. So consumers may read duplicate or maybe can miss messages due to offset mismatches. So that is one of the big challenges. Also, compatibility is a big one. Source and target Kafka clusters might have different versions sorry, might have different configurations or maybe schema enforcement policies, and that can break consumers. So that is another big challenge. Also, the security is another landmine. ACLs, authentication methods, and client authorizations must be replicated precisely. And finally, the topic ownership. In our experience, topic or ownership is often unclear sometimes. If you don't know who owns each topic or how they are used, migration become risky. Okay. So to reduce this risk, we recommend breaking the migration into these three structured phases. That is the pre-migration, where we audit, plan, and simulate. The execution itself, where the live migration using tools like UniLink actually happens. And the post-migration, that is switching consumers and validating everything. So UniLink is designed to support all of these three phases, especially by enabling bidirectional replication and offset thinking, and the things that also Dustin mentioned in the demo in his really quick Kafka migration. But yeah, so can you please go to the next slide, Canon? Thank you. So here are some bullet points in each phase that I want to touch really quick. So in pre-migration, the key in our experience is visibility. Start by listing all topics and identifying producers and consumers. And this helps to prioritize what needs to move and what can wait. Next, you can classify your data. Some topics are mission critical and others are archive logs. So you can focus your attention accordingly. Also, you need or you should decide early on your cutover strategy, right? Maybe you can use a blue-green strategy or a dual run strategy or a progressive migration. I mean, blue-green is when you run both all the new environments in parallel, then switch traffic once the new one is ready. Dual run is when when both clusters run and consume the data in parallel, and you compare the outputs until confident. By the way, this dual run strategy is supported by UniLink, and we saw it in the demo really quick when we saw how in the StreamNative consumers started to consume actually the data before all the switch, right? So the progressive migration, you migrate topic by topic or team by team. Ideal for large organizations or low risk rollouts. Yeah, but in this pre-migration also, you need to plan for a schema compatibility. Whether you are using Confluent schema registry, or maybe you're using a Picurio registry, you need to align how schemas will be handled. And finally, for sure, you need to configure the new cluster. I mean, the target cluster, and stress test the target cluster before migrating anything to leave, right? Okay, so for the migration execution itself, the key steps in this execution phase, the most important move is the one that I mentioned here in my first bullet point, that is enabling replication. You can use, for sure, tools like Mirror Maker, UniLink, or Confluent Replication. And I will talk about this stream in deeper detail in a couple of slides, but I want to mention real quick that here's where UniLinks shine, right? Because it can mirror topics, partitions, and offsets in real time with schema and ACL awareness. So you'll want to ensure also topic configuration match. I mean, same number of partitions, compaction policies, retention windows. I mean, don't just copy topics, but configure them intentionally, right? Next step is shift consumers, but slowly, one team or use case at a time to read from the new cluster, right? And then offset syncing is often a pain point, but UniLink automates it and helps ensure you don't double consume or skip any messages. So, and finally, validate the messages for sure. Use hashing or data integrity to make sure everything matches while you're doing the actual migration execution, right? And then we go to the post-migration best practices. So once all the consumers have shift, it's time to finalize. First, we need to disable replication, decommission the old cluster, and perform deep audits to ensure message integrity. So you can count records, sample hashes, and verify timestamp, for example. Then you can run a post-mortem. It means what worked, what failed, how can the runbook improve, and all that stuff. Where possible, also, we recommend that you should automate this whole process using GitOps. UniLink actually integrates with GitOps friendly workflows, allowing declarative replication policies, repeatable pipelines. So it's a really good tool in this automation process as well. So before I continue with my last comments, I think that Kandan has more suggestions and best practices to enrich what has been said. So Kandan, if you want to go ahead.
Sure, yeah, absolutely. Thanks so much, Memo. That was really helpful. I think it's careful planning always helps. And I want to just add a little more to what Memo said, particularly around when you are switching your Kafka clients from your source to destination Kafka cluster. I think a little bit of what I'm going to cover here is going to be more in the context of UniLink, but it always helps to start with monitoring your message lag. There's always a lot of historical data which is going to be in the process of being replicated. So, keeping that to almost near zero is always helpful. And then there is a series of steps, I would say. We recommend sort of following, like you follow a certain specific order. It always makes it a little more graceful to kind of switch over your clients. You start with stopping your consumers on source cluster. And this would be kind of prepping for the cutover. And I think this is the next step would be more about validating your consumer group offsets. And this is an important aspect because if that's not planned well, as like Memo was talking about, I think your clients, once switched, could start reading from the incorrect record, right? You want to make sure that it's gracefully transferred and it perfectly starts reading from the right record actually after it's switched. And then you start your consumers on the destination cluster, and then you follow the order of kind of stopping the producer on source cluster and specific set of steps here as I've listed. So I think this is what I would recommend. I think what we're sharing today is a generic set of guidelines. I think if you all are in a situation where you want to talk to someone who knows more about it, I would encourage you to talk to Nexaminds team, and I think they'll be able to kind of carefully evaluate your current situation and then provide you some guidance there as well. So and then finally decommissioning your migration infrastructure. The last step 3 is again a scenario where if you don't have a real-time data lakehouse scenario where you want to keep your source cluster on and also yet replicate the data for other new projects. If you're convinced that no, you want to move to, let's say, StreamNative's cluster, then I think then you're all set to sort of, decommission your source cluster, right? So this is what we would recommend. I think careful planning around how you switch over your clients as well. If there's a particular order which always helps in graceful kind of switch over. All right. So Memo, if you can cover a little more on the different tools available out there, what your thoughts on that? It's going to be helpful for our audience to know, get a broader perspective rather than hearing just from StreamNative about the tool. So anything you can share is going to be helpful here.
Yeah, thank you. Yeah, finally, I wanted just to mention some other tools that you can take into account. For example, here I mentioned 3 main tools for Kafka migration. For sure, we have UniLink, also Mirror Maker, and Confluent Replicator. So Mirror Maker is an open source Kafka tool built on top of Kafka Connect, as we know. And yeah, each of these 3 tools has some strengths and limitation, but due to the time, I want to focus on, for sure, UniLink. And yeah, I will say that UniLink has amazing strengths because it is Kafka compatible, but not tied to any vendor, because it works across self-managed Confluent, MSK, Red Panda, I think, Pulsar, etc. So it supports also selective replication, topic filtering, message filtering, field level filtering, and includes also offset synchronization, ACL schema mirroring, which, for example, Mirror Maker lacks. So it also it's built with cloud native scalability and GitOps compatibility in mind. So that is a good thing, and also supports a hybrid replication, meaning that you can mirror from Kafka to Pulsar, for example, or vice versa. For infrastructure as a code, we use and recommend Terraform and Helm to manage cluster declaratively. And for monitor, you can also take a look to Prometheus or Datadog to track lag, throughput, and health in real time as well. So the last thing that I would like to say is that in Nexaminds, we for sure can help clients from retail to logistics or whatever. When it comes to performing large-scale Kafka migrations, we bring zero downtime playbooks, monitoring blueprints, and automation strategies. So now with this new partnership that we have with StreamNative, whether you're using Kafka or moving towards to Pulsar maybe, we support both ecosystems with this new partnership. So we can take advantage of UniLink to bridge Kafka to Pulsar in production grade systems, or to do this Kafka migration. To summarize, Kafka migration is absolutely doable, but only with preparation. So remember, inventory everything, test everything, and automate everything is like my last recommendation. And for sure, use a tool like UniLink to handle the heavy lifting, right? Especially for real-time replication, offset syncing, and schema consistency, and all that becomes risky if you don't handle in a good manner. So and don't do it alone. Our team in Nexaminds can help make this journey predictable, safe, and faster. So thank you so much for your time. I hope this gave you a useful blueprint for Kafka migrations, and I happy to dive deeper into tools, challenges, or whatever you want to talk about further. Thank you.
Got it. Awesome. Thank you so much, Memo. I think so. I would repeat what Memo said, that don't, you're not alone, just like, trying to figure this out yourself. I think from a tooling perspective, definitely get your hands on UniLink, try that out. And I think it's a very visual tool to kind of help you replicate the data and all the configurations and everything. And then, of course, talk to Nexaminds about your end-to-end project. One thing which I would quickly, as I summarize today's session. We spoke about use cases. We spoke about the tooling. One thing which actually we didn't get into too much is, how declarative and visual the universal linking tool is, because we have very limited time and we are approaching the top of the hour, so I'm going to speed up now. But the key thing here is, what you saw in the demo was a lot more of a quick scenario, pushing data and seeing the replication, and ultimately seeing that data land actually in a low cost object storage. And from there, it was queried by Snowflake, right? And then we saw it on Snowflake. But the process of creating the jobs for data migration and schema migration are created in the UI, or it could be done from API as well. So for someone who's really getting their hands on, I think the UI experience is really good. I think I would recommend you to try that out. There are other demos which Dustin has created, which will sort of provide you that guidance as well. So anyway, so we covered UniLink today. I think also for your end-to-end needs around data platform, and to talk to an expert, definitely talk to Nexaminds around that. StreamNative Universal Linking is in public preview. So you can log into StreamNative Cloud, and I think you should be able to get your hands on that. So I'm going to just quickly share a couple of resources here. Feel free to scan this barcode to get to the video from Dustin. I think this is actually a more broader demo, which covers much more details around UniLink and the replication. And then I think today we would like to share a Kafka migration guide. This is a guide being put together to kind of help you plan your migration as you perhaps like wanting to move from source cluster to a destination cluster. And what are the different things to keep in mind? And then how can sort of UniLink help you with that process? We've also listed the contacts of our SI partners who can help you with that. You can go through that detail. So I think that's the URL. Let me just quickly highlight one or two more things. We have a data streaming summit coming up. This is a virtual summit. We do 2 summits in a year. One is the in-person event, which is usually around September, October timeframe. We did one last year in October. And now we have another one coming up actually on May 29th. This is a virtual summit. So if you're interested, please scan and then participate in this. I think, this is a very broader event for all kinds of basically all things streaming, right? It's not really StreamNative specific. We are open to inviting anyone to talk about, streaming technologies and, all the innovations which are happening in that space. So please scan and participate. Also, if you want to actually new to StreamNative, please sign up for a trial if you want to get your hands on it. If you want to book a demo, you can definitely go through that URL. Perhaps just take a screenshot of this right now so you have access to this and reach out to us. So I know we are top of the hour. We are just like 1 minute away, but I can just quickly see if there are any questions. I can take 1 or 2 because we are pretty much reaching the top of the hour. So let me just bring up that. Okay, so I think that's one question. Probably this one is for Nexaminds, perhaps. What has been your experience with near-shoring talent in terms of acquiring and retaining? How do they perform working with the client workforce? Tej, can you take this one?
Yeah, sure. So Mexico definitely has a lot of advantages. We're based in a city called Guadalajara, which is also known as the Silicon Valley of Mexico. It has quite a lot of good universities, a lot of talent coming through, and our talent acquisition team is very well entrenched, very experienced in tapping into the talent across multiple domains, be it data engineering or even SAP, and different kind of roles, QE, .NET to cloud technology. So we're getting a good amount of talent coming out of Mexico, and we have very low attrition rate. Surprisingly, I would say the last 1 year, I would say only we've lost 1 or 2 consultants at most, and our clients seem to like what working with our consultants based in Mexico. There is hardly any language barrier. Time zones are pretty much similar, particularly with the West Coast. So things are working out very fine, both for our consultants and for us. And we make sure that the clients, the consultants have avenues for training. We have guilds where people share their knowledge, participate in internal projects. So we've gotten a good team working cohesively together and performing really well. It has been a good experience this past 1 year.
Perfect. Awesome. Thank you so much. I think looks like there's a quick follow-up and we can just keep this short. How involved is Nexaminds in post-migration monitoring and support?
Yeah, I think that I can take that. I mean, to be really quick, because we run out of time, we are fully involved in the post-migration monitoring and support. Our job doesn't end after the migration. We implement full observability and support data validation, incident resolution as well, and optimization after the cutover. So that's how we are involved in the post-migration.
Okay, awesome. Awesome, great. So I'll just take one very last one. I think this is probably for me. Considering that UniLink is in preview, does it need to be enabled on StreamNative cloud environment? So no, you don't have to. It's in public preview, so which means that you log into StreamNative cloud, whether it's signing up for a trial or if you already have an existing account, you log in and you will find a link, will say UniLink preview, public preview. So it doesn't need to be enabled. It's already enabled, and you can get started with it. You click on it, and you'll start seeing the UI to create your application jobs for data and so schema migration. Yeah. So absolutely, do give that a try. I know we're on top of the hour, but I hopefully you found this session useful, and we will definitely to all the people who are registered, we'll send out a recording of this. And if you have any questions for either Nexaminds team or StreamNative, please reach out to us. We'd be happy to get on a call and chat more with you about it. Right. Again, I would thank again to the Nexaminds team and Dustin. Thank you so much for being a part of this session today. And we will end this session today. You all have a nice day.